Go. Okay, the recording has started. I am really excited to introduce our newest of partners from Crowdbotics. This is Anand Kulkarni of Crowdbotics, who is here to talk about CodeOps for nonprofits. So
all right, thank you so much. It's great to be here and excited to talk about a topic that should be of interest to a lot of folks here in the audience, certainly of interest to the Blackbaud community. Hot topic for us here at Crowdbotics, which is CodeOps. So I'm Anand Kulkarni. I'm the CEO and founder of Crowdbotics. We're a CodeOps platform, and I'm going to be talking about how teams can unlock development efficiency using the emerging movement of CodeOps, especially focused on the nonprofit and NGO space. So as we all know, the buzzword, the trend of the year is generative AI. Generative AI has had profound impacts on all kinds of fields, but for those of us who are software developers, it's had a profound and fundamental opportunity and challenge that it's created for us. On many levels, generative AI presents the opportunity to change everything in how we think about software creation. And many of our organizations are still thinking about how we're navigating these changes. We think about these as basically two big trends that are happening here. So for most of our careers, code has always been viewed as our organizations as this strategic asset, right? Where we are pushing digital transformation, we're leveraging tools and technologies to take the work that we're doing both on a stakeholder engagement model and in the actual interventions that we're doing to create technology opportunities, competitiveness. The code is our strategic asset and this core IP. And now we've got this surprising trend that's showing up with generative AI, where developers have this opportunity to start creating very cheaply this infinite amount of code, which is both an interesting opportunity and a challenge. Using tools like GPT or large language models integrated into some of our development software in the form of GitHub Copilot or into our IDEs, we have the opportunity to start creating lots and lots of code. And as developers, as IT teams, we start asking questions about if this code is actually right. Are we generating opportunities to scale and move faster? Or are we creating the opportunity to generate lots of risk, unlimited technical debt, or ways that we can really slow down our development processes by introducing unhelpful code or detrimental practices into our cycles? So we're thinking about these two models coming together in a movement that we are seeing folks pick up, which we're calling CodeOps. It's a universe of hybrid development. The idea that developer teams can start to use generative AI safely, securely, and in a universe where they really think hard about code quality and trust, while maintaining the ability for their organizations and their dev teams to start using code in ways that they're confident in. What we think about as a code reuse model or a code reuse strategy, making the best of both worlds here. So this is CodeOps, the idea that we are able to build using generative AI and reusable building blocks of code in ways that meet our organization's best practices for how we can create software, maintaining our rules for compliance, governance, safety, and security, using code that we've written off the shelf and stored safely in places where it's useful, and using generative AI in places where generative AI is right. Okay, so we think about what's emerging here as a hybrid human-machine software development lifecycle. A universe where we're using human software engineering teams for the stuff that we're experts at, scrutinizing the process, writing custom code, making sure that we're acting as a sanity check and an accelerator on what machines are doing, and then using generative AI in places where we think generative AI can accelerate our process. And there's some things that generative AI tools are great at, there's some things that they're really bad at, and two things that we're seeing that are pretty consistently places where they can be effective are in product planning, thinking about ways that we can take the requirements of our less technical users and translating them into technical language using large language models by helping that group of stakeholders end up doing better and performing better by using LLMs, and then in helping use AI to actually write pieces of code that we maybe don't want to write ourselves because it's something we've already written, it's somewhere in our code base, it's pieces of code that we might not want to take the time to sit down and write, but we should just ask our development tools via AI to go and find for us and pull off the shelf and bring up where relevant. So this is a three-pronged stool. We see hybrid human software engineers on one hand, who are being supported by their regular copilots, their tools for writing software, LLMs that are being used to help our non-technical stakeholders speak our language, build software requirements in ways that we feel good about, and then using AI to reduce the actual amount of code that we need to write by pulling stuff off the shelf that we've already whitelisted. This is CodeOps, okay? So the old process here was that we would rely pretty heavily on developer-written code. We'd be out in the open source ecosystem pulling stuff out, working on frameworks, but there was a lot of manual work that's involved in the conventional software development cycle. Writing specs from scratch, debating and researching technical approaches, looking at open source models, and really doing a lot of iterative development, right? Whether it's waterfall or agile, something between, we are picking stuff up as we are encountering it, and we might see a given problem only once. This means that we end up reinventing the wheel and that there's room for error that we've introduced into our process. The CodeOps universe is the idea that we can ensure code reuse driven by AI is done easily across development teams. We start by developing and maintaining a private catalog of what we'd consider to be our organization's own modules, reusable components, and building blocks of software that we typically create, and then requirements, pieces that we want to put together one by one and have our users use over and over again. Things like our security rules, our compliance requirements, pieces of documentation or copy, our brand guidelines, our donor-facing guidelines, and more. What we find in most customers who are using a CodeOps model is that 70% of code ends up becoming reusable. When we look at folks who are creating software, they're saying only 30% of what we actually create when we're building apps is truly new. Things like authentication flows, database structures, DevOps pipelines, API calls and connections, our brand guidelines, our style. These are all things that are consistent across our applications. The stuff that we actually want our developer teams to be working on is just the stuff that's new and custom, pieces that might be unique for a given application's requirements. And everything else, we want to figure out how to identify at the planning phase, how to pull into our products, and how to snap together these systems before we've actually started writing code so that most of our application approach ends up focusing on this question of just what's new and unique. And that happens both in the planning phase with BAs, PMs, and architects on our teams putting together and planning with these reusable elements. Our developers who are thinking about just what is different and what needs to be written from scratch, and then on a test basis, understanding which pieces need to be tested in unison in a universe where we've pulled a lot off the shelf. The end result is a process that's much simpler to actually build. So we think about this in 4 special places in the nonprofit ecosystem. The first is the notion that we're using AI safely to try and provide easy and rapid ways to prototype applications on a requirements basis to allow us to accelerate the process of creating software. We can think about up-leveling our developer teams by making sure that everyone who is working is using the same library of stuff. The actual components and building blocks that we end up constructing software with end up becoming consistent between the applications that we build. The interesting parts that we end up working with from a CodeOps model on compliance is the idea that we're able to construct practices that are repeatable across the different applications that we construct. Elements that are templatized or standardized have the ability to pass compliance once, and then there's a pipeline of viable, traceable IT assets to allow us to mitigate risk in the applications we're building. And the end result is that we can do more with less. We can end up accelerating our actual returns on software development processes and accelerating efficiency by integrating in CodeOps approaches. Okay. So this ends up allowing us to increase speed and efficiency without sacrificing the IT governance that usually comes from historical approaches in this space, like telling people to go and look at low-code tools, or telling people to go figure out how to snap things together using workflow systems. This approach allows us to merge a couple of different worlds that have historically been apart. The idea that we are accessible to non-developers who are using AI tools to help participate in the process, increasing efficiency for our developer teams by letting them work just on the parts of the application that are truly worth their time and new, and then ultimately auditability and protections for IT teams who have access to the full code base. So here's a typical workflow for what we see end up customers and users who are following the CodeOps model or AI model end up using. They're splitting the parts where non-technical users are participating in a process, having the non-technical groups and stakeholders work with AI to define their requirements, to look at the module catalog via that AI, to pull out components that they think are interesting, to put together prototypes on their own that are generated out by a machine using off-the-shelf parts, and then having our technical teams focus just on the ideas that are interesting and new. Module creation, certification, and maintenance of new software components that they want their organizations to make use of, directing the large language model or AI that they're using to plan to actually create components, to use components that they have created and integrate those into their actual delivered applications, and then delivering those end results on certified code that they end up producing. So that approach ends up merging the two ecosystems that have historically been apart. Okay, so looking a little bit under the hood, what do we talk about when we talk about modules? Which parts of an application are actually truly reusable across software that we might want to build? So we think about software high level as being broken out into a few different layers, starting with the specifications in the beginning, the actual attestations we're making on an architectural basis, things like our policies, our configurations, our rule sets, our compliance, the scaffolding, the actual architecture of the app, and then the actual meat of the software itself, which we consider to be the UI, the style, the layouts, the components, our front-end logic, connections against third-party APIs or internal APIs, and then our back-end logic, our data models, and our tests. So not all of this ends up becoming reusable. We think about some pieces that are more likely to be custom and more likely to be unique for a given application, and some pieces that are likely to be consistent across different products we create. So if you're implementing a CodeOps model in your organization, you can think about looking at the approach you would take for software creation as standardizing along these ways. Elements like scaffolds, the actual architectures that you are creating inside your organization to build and deploy applications end up becoming good classic examples of structures you'd want to modularize early in the process, because many applications you construct are going to follow the same sets of requirements in terms of what your DevOps configuration might look like, what server instances you might spin up and maintain, what basic framework you might construct, and what authentication flows or other security requirements you might have. Modularizing your scaffold allows you to standardize the approach you're taking when you demonstrate to end users or to your own security groups that your organization's applications are compliant, that you're following consistent policies, and that configuration is something you can control. You can also find a high degree of customization, of reusability across API connectors. When your organization is hooking into something like Blackbaud's Sky API, you can pull out and standardize that approach into a given module so that you don't need to reuse that every time. Other elements like UIs are also great candidates for reuse across applications, since brands, layouts, and even our specific guidelines for how we might have things like typefaces or pixel perfect configurations of individual screens are likely to be consistent between different applications that we build. And those are great candidates for pulling out and modularizing. Even things like data models are phenomenal places that we can look at actually creating modules, since we don't have to reconstruct a user object or a donor object or a customer object or an event object from time to time. We can just save that one, modularize it, and reconstruct it. We've also noted here that you can also create structured specifications for reuse. The idea that we can reuse actual specs helps us in communicating with non-technical users to allow them to go through and create specific reusable components when they are writing software. So they can think about using elements that are off the shelf instead of pulling in elements that are brand new every time. Okay. So here's an example of what this looks like. If you're trying to create a module or modular strategy inside your own organization. And we think about this as basically a three-part workflow here. Let's say that you are a typical organization trying to construct or maintain a universe of applications. And some typical examples that we see inside the NGO ecosystem are things like applications for managing donor outreach and engagement, maybe in conjunction with systems like your Razor's Edge CRM. Things like your event management application, where you might be running a series of events over the course of a year. You need to structure and think about how you're going to launch a unique application every time or manage a system of applications each time. We might have our ongoing donor portal, where we're engaging with a number of groups on the other end. And then you might have a number of internal applications that you're creating as well to engage with internal stakeholders or connect various systems. So typically what we are recommending individuals do if they're implementing a CodeOps strategy in their organization is to start by identifying a set of modules that they can create that are common between these application structures. Things that they can standardize, modularize, and then distribute out either to their AI system or to their stakeholders or both to allow them to construct consistent approaches for approaching and maintaining applications. And this is just an example of some of the 10 most common application modules that we see people creating around third-party systems or reusable software elements that they've constructed in-house. Things like your authentication flow into a CRM like Blackbaud, your donor management systems, your calendar system integration, your payment processing integration, your social media integration, invoice automation, chat, document storage, your permissions and user objects, and your vendor management systems. Each of these would be their own individual module inside your own organization's catalog that you'd identify, link up against a specific building block set of code, and then structure in a way that can be actually accessed by an artificial intelligence system that you're using to help write your specs. Then when you're doing specification generation or planning, you can stand back, specify that you need your end users to give you requirements, pass those into your LLM, and have your LLM reference these specific modules to describe how the underlying application will work. And if you're implementing a CodeOps strategy, you will typically have that process result in generation of a code base using the pre-specified modules that you've constructed, allowing you to focus on finishing out that application using your last mile work just carried out by your own internal dev teams. So this approach is a radically different way to think about building software. We're taking our portfolio of apps that we have historically treated as disparate objects that have to be maintained, tackled, and supported individually, and turning them into a common system for building applications using a series of modules, and then allowing our users to talk to us and plan with us using artificial intelligence, which is a very different approach than how we've historically approached software creation problems. Okay. So if you're an ISV in this space, you can also think about this from a perspective of high margin code reuse across individual verticals. There's a number of places where we end up seeing teams who are implementing CodeOps specifically think about driving modules that can be reused across their ecosystem. So there are some that are high overlap and consistently reusable across their customer bases. But then there's others where we see that people just modularize consistently the same kinds of things that end up becoming useful across multiple customers in their ecosystem. Things like course management, streaming video, and application forms, or student portals, quizzes, and live group work are all consistent examples of modules people create and use over and over again in the education space across multiple applications. And these are the kinds of things where individual stakeholders may step up and say, hey, I need my own element for course management or my own system for streaming video. And the answer should be consistently from our organizations, hey, go use the modules we've already got available to you, discover them on your own, and we'll help you the process of going through and setting these up. Then there's plenty of things where we can end up seeing individual groups inside healthcare, environmental work, and researchers who are creating individual application modules that end up driving significant reuse in their own ecosystems. Okay. So the bottom line that we end up sharing with our own organizations when they're implementing a CodeOps strategy is often thinking about what's the ultimate business impact. We can talk about 70% code reuse. We can talk about our lives being better as IT teams. But really what we end up seeing here and what we want to see is sort of dollars and cents to our own IT organizations. Usually we end up recommending that folks who are talking about implementing a CodeOps strategy talk about two sides of it. The cost savings that you get from code reuse, the amount of reuse, and the time savings you get versus building the old-fashioned way. And often those cost savings are not just the upfront cost savings of building software once, but the fact that we have much less code to maintain, a lower surface area driven by what we're creating, ends up allowing us to substantially reduce the amount of long-term costs that we need to spend because we're maintaining modules, not an entire set of disparate software systems, but individual components that we can push out to the rest of the ecosystem. And then, of course, the fact that we're using AI to drive down our actual planning cycles means that we are pushing out faster time to market at the end of the day, which is higher revenue or higher inflow of cash, and then greater cost savings on a business perspective, both of which carry a lot of value for our organizations when we think about what this can be. And typically we end up seeing groups who are implementing CodeOps talk about a 70% code reuse model over 2 years, getting them to about a 4x ROI, 400% return on their investment in rolling out a strategy like this, which is pretty good from a dollars and cents perspective. Okay, so that's the CodeOps movement. We've been excited to share quite a bit about how this emerging movement is helping folks take advantage of some of the innovations in AI. We have a sponsored session later today where we'll show you a live demo of a CodeOps application creation process on our own platform, Crowdbotics, in action. We'll show you how to build an app with the Sky API authentication module. It's just one example of a reusable module. And we'll show you how to do it in just a week. We'll show some live demos of how to write specs with AI and how to write code with AI, referencing those modules. We'll show you off some of the cool AI-powered screen generation and code generation systems, as well as one approach how you can create modules on the Crowdbotics platform. You can also feel free to stop by our expo booth anytime in the rest of the event. We're giving away a free AirPods Max headphone set to one attendee. So we'll look forward to seeing you guys there, and we're happy to take some questions now about the CodeOps movement, AI, or anything else that we talked about.
Got a very silent crowd. There were a large group of people who were here throughout the presentation. No questions so far. I actually find it quite fascinating. And I've got a lot of tabs open on my browser where I was reading more. Oh, got a very silent crowd here.
Thanks, Tony. Yeah. I think it's been fascinating to see the different places that folks are using AI to reuse code. The core question that people sometimes ask is, when you're asking a system like ChatGPT to reuse code out there in the world, are they reusing code that you have the rights to use, or is it somebody else's code? And the answer with systems that are out there in the world, like ChatGPT, is you don't always know. The answer for teams who are implementing a CodeOps strategy is usually you should use a system that has been fine-tuned on your own code to make sure that you have IP rights to use it. And that's why many organizations have said, hey, we shouldn't be using OpenAI solutions. We should be using our own private code development systems, which has been exciting for that. So Ben asks, what AI should we be using for generating code? Great question. The most famous one here is ChatGPT. And a lot of organizations, IT teams have said, don't use ChatGPT for the simple reason that you can't guarantee IP rights for the code that's being generated. You also can't necessarily guarantee security, and you can't guarantee compliance with your organization's own rules when you're using a system like ChatGPT. On one hand, that's great because as IT professionals, we'll always have a job to make sure that these systems are doing what we think them to do. But when we're actually practically trying to answer the question, which system should we use? The basic approach is that you want to use or use your own model. When I say your own model, I mean a private instance of a AI system that is within your organization's own control. So as some examples, there is an Azure resource you can spin up that specifically is focused on having your own private OpenAI instance. And it's just a copy of the big public one, but it's private, which means that no data is shared back to OpenAI. That doesn't prevent you entirely from having the risk of generating code that doesn't belong to you, but you can fine tune and control that model in ways that you can't for the public model. So that's one example, one instance that you can use. The other one that's interesting is actually it's a series of code generation modules that have been put out by Salesforce. And they open sourced it so anyone can use it. The model that they end up using is called CodeGen. And they open sourced it a few years ago, just I think a year and a half ago. It's actually now been improved quite a bit. So it's competitive with some of the best systems like GPT. And you can download it and load it up into AWS or your favorite ecosystem and generate code directly from it. It's pretty powerful. So those are just two examples. There's actually new code generation AIs, usually open source, that are put out there into the ecosystem just about every week. Those are the two most famous ones that you can use in a safe and secure way. Typically, if you're rolling out a CodeOps strategy, you should try to plug in one of those systems into your own open source universe and give it a try. Great.
Okay, I'm going to stop the recording.